evil, and I have no clue yet.
I have Michael Wazorski, same with him, I don't know.
This sounds good.
Jacob Kahn, aerospace engineering.
I'm in between mechanical or software.
Tony.
And King, computer engineering as well.
Bryce Stevens, electrical engineering. Jonah Dietenberg, either civil or mechanical. I'm not sure yet.
Okay. So for you guys that said mechanical, what types of mechanical stuff are you thinking? I'm sorry?
Oh, working with engines.
Okay.
Yeah, I don't know.
Okay. Nice. Well, again, my name is Michael Zagar. I actually work at a local firm here, Excel Engineering. Anybody heard of Excel Engineering? Anybody familiar with what we do?
Aren't you mostly like buildings?
Yeah, that's exactly what we do. So anything you can think of, as far as design or engineering of buildings and the property those buildings sit on, we do. So we do civil engineering. So if you're interested in civil, that's one of the things that we do at Excel. Site design. We've developed subdivisions before, site designs for the buildings that we work on, etc. We do architecture, we do structural engineering, we have multiple groups of structural engineers that have different specialties. When you say mechanical, what I do is essentially mechanical engineering. We design HVAC and plumbing systems for buildings. Electrical engineering, we do electrical systems for buildings. We have an AV group that does sound and video and lighting controls and motorized blinds and all that type of stuff. We have an IT group that can integrate computer systems, design and installation into buildings. We also do, we are also a big dairy building engineering firm, so we actually have a food group. So if you ever go into a cheese plant or something like that and you see all the stainless steel tanks and pipes, we actually have a group that designs that as well. And we're probably the only engineering firm in the industry that actually does that. Most of that work is done by those people that install that. So we're pretty diverse. We do all different kinds of buildings. So the aerospace stuff, the engines, that kind of stuff, I'm not going to be able to specifically address. But a lot of the skills and a lot of the things that happen in an engineering firm or in an engineering environment, the same kind of stuff I'm going to go through every day. So I guess to start out, like I mentioned, my title at Excel is actually project manager. My license is actually that of an HVAC designer, and that's what it actually says. It's designer of engineering systems. The state of Wisconsin offers a registration for people that are not professional engineers that design heating and air conditioning systems, plumbing systems, or building electrical systems. And they're referred to as designer of engineering. The reason I have that is because when I was in your shoes, I didn't really try to pay too much attention to what I was going to do after high school. I was only focused on getting out of high school and really missed my opportunity to go to a good four-year school at that point. So I've been in the work industry now in engineering industry for 25 years and have done it with only a 2-year associate degree from Milwaukee Area Technical College. Not the way I'd advise anybody to go, because it's a long road starting from the bottom to climb your way up. You're better off getting an engineering degree, and there's a lot of good schools in the state of Wisconsin, in the UW system, MSOE, Marquette, other places around the country. So when I mention that, I'm not a professional engineer, not licensed as a PE. PE can do a lot more than designer of engineering systems can do. My limitation is to oversee and stamp HVAC drawings that are submitted in the state of Wisconsin. That's the extent of my license.
So
Yes.
then is a PE responsible legally for the rest of the?
For my work?
For, what is a PE responsible for?
So a PE has the ability to, a couple of things. One, if you're a PE, you're registered in a particular state as a PE, and you can oversee a number of different disciplines. In Wisconsin, you can oversee a number of different types of work as a PE. So if you are in a firm and you're doing a project and you're a mechanical engineer and a PE, and there's electrical engineering work, you can still oversee and be responsible and stamp that electrical engineering work even if you're a mechanical engineer. The other thing is you also have the ability to take and transfer your PE. There's exams to take or forms to fill out or whatever, and they vary from state to state, but you can become registered in multiple states and be able to do work in different places around the country. In my case, I'm restricted only to work in Wisconsin. So As far as the HVAC process, I do essentially the same thing as a HVAC mechanical engineer would do. Again, my limitation is there and in the state of Wisconsin. So, typical day for me, and like I said, I started out at the bottom, so my typical day has changed a lot over the course of the last 25 years. I started out as a CAD tech with a 2-year degree. So what that involved is essentially sitting at a computer. You guys use any kind of engineering software for CAD development? What have you guys used?
Autodesk.
What type of Autodesk? Autodesk makes a ton of
Autodesk
programs.
Inventor.
Inventor?
Yeah.
Okay. So Inventor, you can do things in both 2D and 3D, correct?
Yep.
So Autodesk also makes, like in the building engineering industry, they also make software called AutoCAD. That's probably their oldest software. Anybody familiar with AutoCAD? Wow. Okay.
Sign of the times.
Pretty old, huh? They also make a package called Revit. Anybody familiar with Revit? Okay, Revit essentially, so if Inventor can do both 2D and 3D and you're doing assemblies, you could model a chair, for example, or Josh, you're in robotics, so you could model your robot in Inventor. AutoCAD is basically a drafting program. It started out as a drafting program where you could do lines, arcs, circles, text, that kind of stuff. So rather than use a pencil and a T-square, you would use AutoCAD. You'd be able to replicate things faster. Obviously, if you build a part once, or a block once, you can insert that multiple times. And that was the strength in AutoCAD in its day. I started using AutoCAD in 1990, if it gives you an idea how old that software is. Revit, and AutoCAD over the years has started to develop itself into 3D. Revit really took it the next level. So when you build stuff in Inventor, if you build a part in Inventor, you can ascribe different properties to that part. You can ascribe materials, you can ascribe strengths, all kinds of things to that part. Revit is the architecture and engineering for buildings that you're used to in the 3D Inventor. So Revit recognizes a window as a window. So if you've got a window frame, you've got glass, you've got a masonry wall, you've got ceiling tiles, all these things it recognizes as parts. And you're literally assembling a 3D model in a virtual environment of all these parts. Make sense? So starting out with a 2-year degree, like if you went to Moraine Park, for example, we've looked for guys to be CAD techs that are 2-year graduates. So essentially what happens is you'll get markups from an engineer or a designer, red marks on paper, sketches, tracing paper, sketches, whatever, the same kind of stuff you guys are probably going through when you're developing some of this stuff. You'll get those, and depending on what level you're at, those sketches may be pretty neat and tidy, or they might be pretty messy and you get to fill in all the gaps. But you'll sit at a workstation 8 hours a day and figure that stuff out and get it drawn up and make those sketches turn into something that is more tangible in its format, a little better to read than a cocktail napkin sketch, for example. So I did that for a number of years. If you're good as a CAD tech, the problem in industry is CAD techs are very difficult to retain. The reason they're difficult to retain is if you're a really good CAD tech, you've probably got the ability to be more than a CAD tech. So those that have that ability will usually advance. If you're not that great of a CAD tech, you're probably going to be stuck as a CAD tech, and you probably don't have the ability to advance anyway, so you're probably not that great of a CAD tech. So there's the problem in the industry. Make sense? Where I went from there, I started out as, like I said, an entry-level CAD tech. Started out with basic markups and filling out schedules and bills of materials and details and pretty rudimentary work. Grew from there into starting to do calculations. You guys have done some calculations, so you know what goes into that. Started out learning to do that, and then began to lay out systems. And over the years went from doing CAD work to laying out and designing systems and doing calculations to overseeing other people, getting other help and bringing them up and training them and helping them to learn and understand systems, to essentially managing an entire project. So now my role as a project manager doesn't involve much CAD work anymore and doesn't involve a lot of engineering anymore. It involves more communication with owners, clients, other engineers, other architects, staff in office, managing workload, et cetera. Yeah,
Did you have to take more classes or more courses?
I actually have not. To do that, it's just a matter of growing in the industry and knowing what the industry, how the industry works. And, we talked a little earlier about sometimes you're going to build something in here and it's going to fail. There's a lot of learning what doesn't work by having things not work. Does that make sense? So, do you guys have any questions? Nothing. Okay. Yeah.
So if the project that you're like overseeing, if they screw up, what happens to you?
So, I'll ask the they. Who is the they in your question?
Like, say the engineers that you're overseeing, say one of their designs fail and someone gets hurt. Does anything happen to you?
We haven't had that happen, but really it is the responsibility of whoever is stamping those drawings as the licensed professional. It's their responsibility that that job or that design is correct. So if I've stamped, like the plans I brought in here, if I've stamped those HVAC plans, which I have, they get sent to the state. If there's something wrong about the design, that's my design that is out there. Does that make sense? Now, usually you don't have failures because there's a checks and balance process that occurs. So it's not just one set of eyes looking at this. I brought it in because it's a school project we recently finished, so thought that'd be appropriate to bring into the school. The number of people in our office involved in this project is, probably a quarter of our office. And we've got 100 plus people in there. A quarter of our office have probably worked on this project. So when you work together on a project, you've got everybody watching everybody's back to make sure the project goes smoothly. So I'm looking at things architecturally, even though I'm not an architect, to make sure that how that coordinates with my work actually works. I'm looking at things electrically, I'm working with the plumbers, I'm working with the structural guys. There's places in here where we have to route ductwork and pipes. We have to tuck up inside a structure because there's not enough height to accommodate it. If you go in your gym, give you a perfect example, if you go in your gym, you'll notice, maybe you haven't noticed, but take a look overhead. The ductwork is all routed up inside in between the bar joints, just to try to conserve the height. So that's one example. So we're all working together. The likelihood of any kind of catastrophic failure is pretty low. The other thing we end up doing is, after a set of plans like this is completed, the architectural, the structural, and the HVAC all get sent to the state of Wisconsin, and they have a series of plan reviewers that look over the plans, and they're making sure everything is done within code compliance. So if there's something they see, that can get caught also before a project's under construction. We have had projects where they're building a masonry wall in the field and they don't short properly. Their methodology on the site to make sure that they're safe and make sure things don't come down isn't properly followed. And we've seen individual walls topple over during construction, that kind of thing. But that's more site issues and making sure you've got things shored up properly, that on a windy day the wall's not going to get blown over. So, yeah.
So are you more like behind a desk or like out on a site?
Most of our work as engineers is behind a desk, but I will share this. We've gotten into, and the new code is now doing this as well. So we've got one particular client that we do work for on a region-wide basis. So we serve them in a number of locations in 15 different states. One of the things they run into is oftentimes their installations of their HVAC systems don't work properly. And you see this because you've got a team of people on a job site trying to assemble multiple components of a building under a certain time frame, looking at plans. Things easily get missed. Things get missed that aren't seen in the plans. Things get missed. Things aren't plugged in or wired connected properly or things like that. So they were having issues with their buildings not operating properly. What they started doing is employing us to actually go out to those stores after they're completed and actually walk through and test and make sure their systems are installed properly and operating properly. So we've gotten into spending more time in the field.
Okay.
Additionally, the codes are changing. So what's happening now is there's a requirement in the new energy code, which the state of Wisconsin will be adopting this year, that systems over a certain size, over a certain capacity, they have to be commissioned to make sure that they operate properly. Because if a system, let's think about the school. So if the system's not operating properly and it doesn't shut down when the building's empty, think of the energy that's being wasted.
Exactly.
So the codes are getting more stringent, but that's the reason why. And in some ways, it opens up avenues for work as well.
Yeah, okay,
So,
thank you.
yeah, good question, by the way.
Both good questions.
Any other questions? Anything else? I'm not sure what else I can really cover.
What else do we want to know from an engineer?
What was your starting pay?
When I started at my first engineering firm in 1991, I probably made less per hour than some of you make in part-time jobs. I started in 1991 at $8.50 an hour as a CAD tech. Right now, I think we start CAD techs probably, I don't know, somewhere between $15 and $20 an hour. So obviously the times have changed. Everything's grown, salaries have grown. It's not a bad place to start with a 2-year degree. Again, where you go from there depends on who you are and what your capabilities are. Obviously, I don't make $8.50 an hour. Yeah. But there's great opportunities. There's a lot of great places to work. Excel is really a great firm because we do something that's a little bit unique in the industry, and that is employee ownership. So almost everybody that works at Excel actually buys into the company. And so if the company's profitable, everybody gains on the profitability of the company as well. So people work really hard to make sure that we're all doing a good job and we're a profitable company. That's what I think a lot of companies could do a lot better if they worked like that, but that's
Do you
just my
have to
opinion.
bill your time
Yes.
in quarter hours or maybe explain what
Great
that
question.
means?
Great question. So every project and everything that we do as a company has a job number. So this plan set was for Randolph School. There's a job number not only for the project as a whole, but each individual group in our office has a job number. So the architectural group has their job number, the structural group has a job number. I have a job number for HVAC, there's one for plumbing, there's one for electrical, the AV guys have their job number. And everybody's responsible for their time. So here's how this works. Every individual that works at the company has a different billing rate. So if you think about, like if you take your car to a shop and they bill you $80 an hour to work on your car, you're paying shop time to have your car worked on. That mechanic that's working on your car obviously isn't making $80 an hour. That pays for his salary, that pays for his benefits, that pays for the portion of the time that that car's in the shop and the lights have to run and you have to maintain power and heat the building and all those types of things. So engineering firm is no different. So everything we do is on a billable hour basis. So when we look at doing a job and we get hired to do a job, we have to put out a quote and say, okay, for us to engineer this job, it's going to be X number of dollars. When we've looked at giving that number out, that number is based on so many hours at this person's billing rate, so many hours at this person's billing rate, and those billing rates vary. So a CAD tech has a billing rate of $58 an hour in our company, whereas a project manager has a billing rate of $129 an hour in our company. So I have to look at how many hours I would spend on that job, how many hours a different CAD tech would spend, how many hours a designer or engineer would spend, assemble that into a number, that becomes the quote. Now I'm responsible, as a project manager, I'm responsible for making sure that we can do that job for the amount we quoted, otherwise we're losing money. So when I spend time on this job, I have to fill out a timesheet. I mean, it's not like punching a time clock like you're in a factory, but I have to fill out a timesheet that says, okay, I spent X number of hours on this project, and in order for me to track what was done in those hours, we have to identify what we did with that time. And everybody who works on my aspect of that will put their time on that job number, will keep assembling that time to know what that project costs. So, and that's done on a quarter-hour basis. Some firms, all firms are different, but quarter-hour basis. So if I get a phone call on this and it lasts 30 minutes, I've got to put 30 minutes on my timesheet, say I've got a phone call to answer, and that it either gets billed to the client, or it gets billed if the project's already been billed out, it gets billed against my project number, depends on the contract structure. And when the project is done and complete and we close it, we settle accounts to see if that project has actually lost money or made money. Make sense? Yeah.
Tell them what happens if, like, let's say, for instance, that particular school, now that those plans are done and sent out, what happens if a change is made out on the field?
It depends on the change. So, perfect example. So, do you guys want to see these?
Yeah.
You guys want to see what goes into these? Come on. Is this,
No,
whose is that? Don't want to wreck it. Anybody ever been to Randolph School?
I'm gonna get that done.
Anybody ever been to Randolph High School? Okay, so Randolph is actually getting rid of their elementary school, and they're actually pulling their entire school into one building. So, imagine if they closed Friendship, and they closed the Early Learning Center, and they built more building here. Obviously, your parking lot would be gone, but this is literally going to be a K through 12 school. So, the easiest way to show it is, civil stuff, just so you guys have a clue what's going on with this. So, this outline here is currently their existing high school. This outline and this outline are where they're going to expand that school. So they're taking that school from probably around 50,000 square feet of floor space up to about 130,000 square feet of floor space. It's literally a K through 12 school, actually pre-K through 12 school. So this is a pretty big job. The drawing set with everybody's stuff in it is, well, you can tell, it's well over 100 pages of drawings. This particular project, we've obviously spent months putting drawings together for it. So I'll start, actually I'm just gonna go through it if you want. Is that okay? Is that all right? So, basic information, there's obviously gonna be life safety issues in a building like this. In the event of a fire, people need to be able to get out of the building and know where they're going. And then it moves into civil, so you guys that are interested in civil engineering, this is what our civil group does day in and day out. And it's figuring out how to regrade the site to make sure parking works and you don't have steep places to park and you don't have exposed parts of the building you don't want. And making sure you're not too close to lot lines and inside of building setbacks or buildings sitting on top of underground utilities, that kind of stuff. One of the things you'll see is you can drive around the entire building. Now, fire department access, obviously as part of life safety is important, so they're doing that. I'll try to go through these briefly. It's a big set, so it's really hard to do that. So there's a lot of drawings that, in a project like this, that go into even the site. Still, site drawings. Demolition work, things that are actually getting taken out of the building. This is a great way to see this. So you can actually see through the page. Here's the existing building as it sits. They're actually tearing off. If you've been there and been in the gym, you know they have that stage area and they have the locker rooms behind it. That whole portion of the building is gone. That's getting taken off. And then all of this gets added. So the gym gets expanded, new fitness and lockers, all the elementary classrooms, new cafeteria, new middle school wing over here, some work getting done on the inside, moving some rooms around in the existing building.
Now, when it comes to actual work, do you contract that out, or is that all your own people?
Everything that's in this set of plans, with the exception of the food service plans, is all done in-house in Excel. So because we have engineers and designers of every sort, from land surveyors to civil guys all the way up to the AV guys, we do everything in a building, which is what we were able to do here.
And that's what makes Excel engineering unique in the industry.
The firm I started with was just a consult. When I started in the industry, it was just a consulting firm. We did HVAC and plumbing only. We worked with, so how that would work is an architect would have a building. They would hire the consulting firm to do that building. We were a completely different company from them. Back then, you didn't transfer information as easily as you do now. We didn't have an internet that we actually worked on to be able to transmit information. Information often got transmitted electronically on 5.5-inch floppy disks. Otherwise, a lot of stuff was still hand-drawn back in the day, and information was sent over in rolls of plans. So it's changed, the industry's changed a lot. Calculations were all done by hand, or mostly done by hand when I started in the industry. 7 years later, when I changed jobs and came to Excel, everything was done electronically. Our HVAC calculations are actually in an Excel spreadsheet that is multiple pages long, where you're inputting the data of the room. So literally, my HVAC calculations look at every single individual room in this building. I look at the load in the individual room, so how much heat's generated by lights and computers and people being in that room. If it's an indoor interior room like this one, you actually never have to heat this room, it heats itself. Even in the winter, this room heats itself. If it's a room like the library where you've got an envelope wall, you've got to heat that. So in the winter, you've got some heat to deal with, but that room also, with lights, people, and computers, does some of its own internal heating. So we look at literally every single room, and then we group those rooms together into blocks, and those blocks are served by individual pieces of equipment. Make sense? But it's in a huge spreadsheet. And that spreadsheet we started with in the middle 90s at the firm I came from, and my boss and I worked with that as well, and then further developed it, and then over the years at Excel have developed the thing to be a pretty high horsepower tool, even though it's literally just an Excel spreadsheet. So,
Do you guys actually build the building then, or do you hand it off to contractors?
the building is actually built by a contractor, or by usually a general contractor oversees construction, and then all the different subs are brought in after. So this building had a few changes, however, actually just go out this week. So there was a bit of a communication gap at the school. So there's an adjacency problem here. Your computer lab is open to your IMC, correct? And that's the way, when this building was designed, that's the way the school wanted it to be. That's why it's like that. In the case of, I don't know if I have the wrong plan. No, we don't have the plan in here. In the case of this plan actually started like that. The computer lab was here. The IMC is actually considered a future classroom. So eventually, as things all go electronic, their plan is they'll eventually do away with an IMC, and that'll become a classroom. But there was an adjacency here between the IMC and the computer room. During the course of design, the administration decided they wanted all the classrooms to have natural light instead of having an inboard classroom here. They flipped the IMC and a current classroom. So the IMC is all interior. There's no windows in it. However, they didn't want to move the computer room. They wanted to keep the location of the computer room. So, Dixie and Miss Jarchow will enjoy this. So we had a little split between the administration of the school and the staff that uses the rooms. The staff that uses the rooms wanted there to still be an adjacency between the computer lab and the IMC. The administration just wanted to move the IMC and left the computer lab alone. So last week, at the end of the week after a meeting, they came back and got with administration and said, no, we really want to move this. And so we literally were jostling these rooms all around in this space and figuring out what the right answer was.
Now all that stuff costs extra money, right?
All that stuff
There's
costs
more
extra money
drawings,
because
more time.
now I've got 2 project managers sitting in a meeting and a designer sitting in a meeting, and we're all beating around how these rooms are going to move. So imagine $129 an hour, another $129 an hour, another guy at $103 an hour. You're billing out, almost $400 every hour you're sitting there talking about it. Somebody's got to pay for that. And obviously, taking rooms and putting them on wheels and moving them around the plan wasn't part of our original scope. So what happens then is those hours are accounted for, and a change order is actually sent to the owner for them. They're making a change, and they pay for that. That's a legitimate change order. In some cases, we also have set aside part of our fee. So instead of spending the entire fee, we set aside part of the fee for construction administration. So if there's things that come up during construction that we need to make modifications to the drawings, or we need to, we review shop drawings, so different components that are put into the building, we actually review those components from the contractors to make sure what they're putting in the building is correct. So there's time also set aside for that. So the owner's not charged extra for that. That's part of our fee, and that gets pushed aside. That money pool, I'll say, gets pushed aside and utilized during construction. But if there are legitimate changes that somebody makes, change orders are written for that. if there's something in our plan that we've made an error in, those are changes we have to make, and those don't get charged to the owner. That make sense? So literally, I mean, we have architectural plans that are pretty involved where you identify what the classrooms are and what's in them, and then literally a separate plan just for dimensions, just so the guys in the field know what they're all doing. Elevation views. We cut sections through the building. Now, remember, the building actually exists in a 3D model. So if you think about, if you've worked with Inventor and you've built parts and they kind of float in 3D, this building's actually done the same way. So when they're cutting sections through the building, and you can see what's in there, it's actually cutting through what the computer understands as a model.
Now, do they actually
full of
make
information.
3D models anymore, or no?
Generally not.
Those
Generally
are
not.
so cool.
You don't have to anymore.
Somebody would
because
actually make the model and it would...
We've done that a few times, not a lot. Renderings are still pretty common, so you'll have 3D view, 3D renderings. This is, you can get almost photorealistic renderings now, rather than back in the day where you had the sketch renderings that, it took somebody with a good artist hand to do a nice rendering, but now it's all software driven, but that software takes a long time to churn through that much data and that much information to do photorealistic renderings. But yeah, we can do that now as well. Matter of fact, in the 3D environment, this picture's not actually very good, but we're able to produce just 3D views of the building that we can present to an owner to make sure that they're happy with it. One of the things we did, and you guys probably experience it here, there's a chiller or condensing unit over on top of the middle school, and in the summertime you'll hear that thing howling. Anybody ever heard it?
Probably.
Probably
Not
have. Nobody
recognized what it
nobody
is.
goes,
Yeah.
what the heck is making all that noise up there? There's a piece of equipment up there. You can see it plain as day from the parking lot. And obviously, architects don't like to see mechanical equipment. So one of the things we did in this is we had actually modeled I'll get to the mechanical plans here. So I have all this stuff sitting up on the roof of the building. And in some cases, some of it gets pretty big. This rooftop unit's about the size of a bus. Well, from this side of the building, it's not so bad. We've got some screen walls over here and some parapets and stuff so you don't see it. But on this approach to the building, this equipment's visible from back in the parking lot and on approach to the building. So we actually had to model that and take different views to see how much of it we could see. We've got some exposed ductwork out here to get into the gym. How much of that's visible, how much of it's not, where do we move the ductwork to make it less visible, where do we position the units to make them less visible. Another interesting dynamic occurs here, and that is we have a tall building where the gym is, and you have this here. The building's tall where the gym is, and it's lower next to the gym. Guess what happens on a snowy day?
Cold.
That pocket where that building drops catches snow. And if it's wet snow and it's heavy, that adds a load to the roof. So there's concerns on how you design a structure there so that can carry that amount of snow. And I have to be careful putting my equipment in there that it's not pulling snow into it or it's not adding more load to the building and making it more expensive. So there's this dance literally between all these disciplines of people trying to make sure everything all works, fits together, and complements one another. So again, architectural set is literally just the architecture of the building without any structure. That is right there. That's that. That's only the architectural right there. So you can see there's a lot more than just architectural drawings, floor plans, and that in here. So structure designs all their foundations. So this is all their dimensions for where they're pouring concrete in the ground to support the building. It's all broken down into different areas just because it's such a big building.
So when you, are you ever been part of an interviewing group?
To hire?
Yes.
Yes, I have.
What do you look for
So
that would help these young men?
a couple of things we do that's rather interesting is, obviously we'll look at a resume first. So what we're looking for in a resume is a couple things. One, that you've got education that is pertinent to what we're looking for. Two, that you, if we're not bringing you in entry level as a CAD tech, that you have work experience that applies to what we're doing. Three, and you may not think about this, but I'll share this now, always remember this. If I see a resume and it looks like that person has jumped from job to job every couple of years, that's probably a problem. Either they have a problem keeping a job and they get let go, or they're extremely restless and they have a problem staying at a job and they move rather quickly. I'm probably not going to look to hire that person, because the last thing I want to do is bring somebody in who we spend time and effort in to train and they just leave.
It's expensive.
It's expensive. Or if that's been a history and they have been usually the first one to be let go during a downsizing or economic downturn or whatever, or for other reasons regarding their performance, it's only a matter of time before the same thing's going to happen. So if you get into the engineering world, and even if you hate a job, and somebody told me this a long time ago and I'll always remember it, even if you hate your job, stay there at least a year. Because the last thing you want to do is get tagged as somebody who's a job hopper. Make sense? So we'll look for that in the resume. The other thing we'll do is obviously, if the resume looks like somebody we'd like to meet with, we'll bring them in for an interview. A lot of the interview really is how the interaction is. We already know the experience. We already know the education. So a lot of it is based on interaction and how that person's able to communicate, how that person carries themselves, really the simple soft skills. There's not a lot of magic to an interview.
You can tell in the first 5 minutes generally
Certainly.
if you're going to get along with somebody.
Certainly. The other thing we do is we actually do some testing as part of the interviewing
Ooh,
process.
interesting.
So potential candidates are actually brought in and do tests so we can see how good their ability is to see things. So when you look at a 2D drawing, for example, can your brain interpret that into 3 dimensions? So if you've done, do you do like orthographic projection drawings?
They do an intro.
The 3D, the 3-sided view of drawings. We're looking for that kind of stuff. So if you can see how stuff fits together, I know I've seen one, there's a Facebook one of all the different colored rings stacked up, and then what would it look like if you're looking at it from the top? Literally, that kind of stuff.
Did you guys develop that yourself? Is that in-house or?
Nope. There's different, firms that handle that kind of thing. Actually, when I started at Excel, and we do this with our upper level people, I actually took a psychological evaluation. That psychological evaluation wasn't to determine if I was stable or not. That psychological evaluation was to determine how my thought process works. It was pretty startling how accurate it is. I didn't put much stock in, mumbo jumbo, whatever. They came back and it was pretty accurate. So it's by answering a series of questions on a couple of different forms, by sitting through an interview process with the psychologist. They can really get a good feel on how you think, what your perceptions are, how
Now, this is
you
entry level.
proceed.
You're talking to the psychologist.
I did at entry, well, I was a little bit above entry level when I came to Excel.
How about drug testing?
We do a drug test as well during the interview process. So if we make a job offer to somebody, we extend an offer based on the psychological, or not psychological, but the aptitude evaluation, and based on a drug test. You fail a drug test, that offer's rescinded. Pretty simple. So yeah, no lemon poppy seed buns during the week before the.
I think they've fixed that. Well, our gentlemen have been doing cardboard chairs from quarter scale, and we'd like you to walk around and they can explain what their thought process was for their chair. And
actually, doing that's great experience too. Josh, I know you know this from robotics. When you go before a judge and they're asking all kinds of questions, or somebody's coming to critique what you're doing, the ability to answer them and carry yourself with them and explain what you're doing in an effective manner is huge in engineering. If you can't explain to somebody what you need done, or what you're trying to, either somebody above you that you're trying to explain how you're going to get a task done, to somebody who is working for you or with you that you're trying to get them to do a task, or to an owner or a customer or a client who needs a solution and you're trying to present that to them, it's a huge part of this that nobody ever thinks of. People think of crunching numbers and doing drawings and developing ideas, but being able to communicate those ideas is enormous.
So go buy your chairs, gentlemen, and they'll come around and we'll give you the verdict Monday.
See that?